And a system of linear equations problem, as I mentioned, asks for us not to solve one equation, but to solve two equations at the same time. So let's talk about what that would actually look like. The first thing you notice is that in a problem like this, we're given, naturally, two equations. In this case, we're given y equals x plus 4, y equals negative 7/3 x minus 6. And the question is, can we find a value of x and a value of y that will not just satisfy one of these equations, but which will satisfy both of these equations at the same time? If we can find such a value of x and y, then we call that a solution of this system of two equations, and then we'll be done. So the first thing we might say is, well, we just got done with the topic 4 in our course, which relates to how do we translate between equations, data tables, and graphs for linear equations. So the first thing we might do is take these equations and say, well, can we understand each of these equations in a different format rather than just as a formula? Can I, for example, understand each of these as a graph? So if I graph each of these two equations on the same set of coordinate axes, y equals x plus 4, that's the red line here, y equals negative 7/3 x minus 6 is the blue line, what I find out is that there actually is a point on this graph right here where these two lines intersect. And that point is going to be the point at which we find a value of x and a value of y that satisfy both equations. Any point which resides on both graphs is going to satisfy both equations. And so when we're solving a system of two equations, what we're doing is we're finding the intersection point of these two lines. So if I happen to have at my disposal an accurate graph of each of these two linear equations, then I can at least, by inspection, come up with approximately what I think the coordinates of that intersection point are. And for this particular system, what do you think are the approximate coordinates of this point that I've highlighted in purple here? By eyeballing this graph, we can predict that the coordinates of this intersection point are something close to negative 3 for the x and 1 for the y. Again, graphs are good at showing big pictures, but they're not good at being super precise. Right? So we don't know for sure, just based on the graph, whether negative 3, 1 is exactly right, or whether it might be some numbers that are close to negative 3 and 1. But at least this gives us a sense that there is a solution for this system of two equations, and that it's going to be something close to x equals negative 3, y equals 1. We could, if we wanted to, take this guess, this hypothesis, and try to see if it's a solution by just plugging those numbers back into each of the equations and see if they, again, satisfy not just one of these equations, but both of them at the same time. So if I try it with y equals x plus 4, that's the red line over here, then I'd be substituting negative 3 in for the x value and a 1 in for the y value, and just seeing whether I get the same thing on both sides of this equation. And sure enough, negative 3 plus 4 is equal to 1. And so the point negative 3, 1 then definitely lies along the red line. But before we know that it's a solution of the system, we also have to check it in the blue line as well. Y equals negative 7/3 x plus 6. And we'll substitute, again, negative 3 for x and 1 for y, and see whether we get the same thing on both sides in this equation. Plus 6. And then here I've got negative 7/3 times negative 3. That's going to cancel the 3's, give me a positive, it's going to give me a, am I screwing something else? Yes, I've made a copy error. Haha, thank you. I need a minus sign here. There we go. Negative 7/3 times negative 3 is going to give me positive 7. 7 minus 6, that's 1. So now, having predicted, based on the graph, what we think the intersection point is, we can then take that guess, plug it back into the system, and find out that, yes, actually, this is the coordinates of a point which lies on both lines. And so this must be that point of intersection from the graph, which is the solution of this system of two equations. So if we have a really accurate enough graph that will let us make an educated guess, then we can just take that guess, plug it back into the system, and see whether or not it works. In this case, the answer was yes. If it didn't quite work, the graphing technique doesn't quite give us anywhere to go from there. And so we're going to need to get a little bit more sophisticated. We're going to have to do this with algebra. But with, at least in this case, it gave us a guess, and the guess turned out to work.